Okay, welcome to this hopefully very short video on graphing rational expressions. This is 5-4, and this is also the last section in Unit 5. We'll have the test next class, so make sure that you're preparing for that. Hopefully, if you're watching this video, that means you're preparing for it. So, we'll move right in. I did this as a warm-up in class to kind of remember everybody about the function of h and k. This first one's a parabola. If you guys remember to our parent functions, going from those to our general equation, most of them had the form ax minus h plus k. In the parabola one, that x minus h is squared. But the h moves your graph left and right. And that one, remember, is always the opposite of what you think because of that x minus. That's a good thing to put on your notes if you tend to forget. K is up or down, and that's exactly as you would think it would be. If it's positive, it moves it up. If it's negative, it moves it down. So this is a parabola with an hk of -4, -5. So I'm going to graph that point right there. From hk with the parabola, the pattern is out 1 and up 1, out 1 and up 3 from there, and out 1 up 5 from there. That pattern exists really just with the parabola, and there's a slightly skewed version of it with the square root graph. But all of our graphs, all of our parent graphs, when they're transformed, have their own little pattern, and that's going to be the same as well with the rational that we're doing today. One thing to remind you of, A right here, this is an A of 1. That's why we went over 1 and up 1. Whatever A is, that tells us what to do when we go over 1 to the right. If A were 2, we'd go over 1 and up 2. With the parabola, from there we'd go over 1 and up 6. Each part of that gets multiplied by 2. Now the patterns with the other parent graphs are a little bit trickier, and that's also the same case with what we're doing today. So it's going to be a little bit trickier than what the parabola does. So I seem to be missing the equation that I meant to have on here. I don't know where it went. That's interesting. One moment. Y equals 1 over x. That is our parent graph, our parent equation for a rational. If I start plugging in numbers, if I plug in a 1 for x, I'm going to have 1 over 1, which is going to give me 1. If I plug in a 2 for x, I'm going to have 1 over 2, which is 1/2. 3 is going to be 1 over 3, 1 over 4, 1 over 5. This is going to get harder and harder to graph as I go further out, because it's going to get really close to 0, but it's not really going to get there. If I put in -1, I'm going to get -1. If I put in -2, I'm going to get -1/2. If I put in -3, 1/3, -1/4, -1/5, same idea is on the other end. But what we need to look at as well is what happens in between -1 and +1. And what happens there are some fractions. So if I pick x equals 1/2 and I put in y equals 1 over 1/2, that's going to give me a value of 2. So I'm going to have a point that I go over 1/2 and up 2, and I'm going to put a point right there. Now, as that fraction gets smaller and smaller and smaller, my value for y gets bigger and bigger and bigger. So this, very similarly, is going to keep getting closer and closer to that y-axis in both directions, but it's never going to touch it. And what that creates, what that is an asymptote. And there's a couple of reasons for that. One, because that's just how the numbers work on this. But two, one of the things we're missing is what is the value of y at x equals 0? And there isn't one, because if we put in 0 for x, we have 1 divided by 0, and that's one of those absolute no-nos in the math world. So what we have at 0 is an asymptote, and we always need to put that in. We'll put that in the notes in the moment. And because we can't ever put in 0 for x, we also can't get 0 for y. 1 over x is never going to equal 0. So this just ends up looking like kind of a little swoop around right up next to the asymptote, approaching it, never touching it. In both quadrants 1 and 3. So we'll fill out the notes that we did in class the other day. So we've got the parent function, 1 over x, the general form, y equals a over x minus h. Some people prefer to put that in parentheses, and that's fine, plus k. In this particular one, hk happens to be where the asymptotes cross. There are asymptotes at, there's a vertical asymptote at x equals h. Vertical, I mean up and down. There's a horizontal asymptote at y equals k. And a, once again, tells us where to go after we go right 1. From HK. Zoom back. All right, so the shape that creates, we're going to first draw in our asymptotes. I'm going to go ahead and put those in red. I would recommend on your notes putting those in a different color as well. It can be helpful. And then I'm going to graph the points in blue, 1, 1, and -1, -1. Those 4 pieces, those 2 individual points and the 2 asymptotes are what you're going to need, aside from the general shape of the graph, which I'll put in a moment. But those 4 pieces, the vertical asymptote, the horizontal asymptote, and those 2 points, you need to graph all those 4 parts. And then you do the general shape. So that little curve. And these are really hard to do nicely and have them look quite right, which is why it's really important that you do the asymptotes and the points on the graph. This first one would actually be a little bit more, well, that was unpleasant. Anyway, you can get the general idea. So if I'm looking at this example, my HK point is -3. Remember, H is always opposite of what you think, and -2. That means I'm going to have a vertical asymptote at x equals -3 and a horizontal one at y equals -2. So I'm going to go to x equals -3 and draw my dashed line to indicate my asymptote. And y equals -2 as a dashed line as well to indicate my other asymptote. And from HK, I'm going to go over 1 and right 1 and make a point, back 1 and down 1, make a point. So a point right there and a point right there. And then I'm just going to go along the asymptote, curve it around, and go along the asymptote and put arrows at the end. It's really hard to draw that you're getting closer and closer without actually touching that line, so I wouldn't worry too much about it. Try not to make it like a hard right turn there, but do what you can. So that's the PR level, just being able to move it around. I always do the asymptotes first. I find that the easiest way to go. Next up is when we have an A value that is different than 1. So this one is our parent graph one, so that's just 3 over x instead of 1 over x. So my asymptotes are still going to be at 0 and 0, so I'm going to draw those in. And this way it's a little easier to illustrate where the rest of the points would be. Now with this would be highly, not this particular one, but having an A that's not 1 is the highly proficient version of this skill. So what I would recommend is, or what I'm going to require is that you have 2 points in each quadrant where the graph lives. So I'm not going to specify 1 and 3 because if it's negative, it's going to be in 2 and 4. Just keep in mind A tells you where to go once you go right 1. So keeping that in mind, I'm going to go from HK, I'm going to go right 1, and because my A is 3, I'm going to go up 3. And I'm going to have a mirrored point in quadrant 3 that's back 1 and down 3. Now, something to note about these graphs is that they are symmetric across their HK point. Like the parent graph would be symmetric across y equals x. So I'm going to have a point that mirrors from this on across that as well, and this one across there as well. So my other point here is going to be at 3, 1, and this one is going to be at -3, -1. So this graph is going to come down and go a little wider than my other one. Well, I guess it really depends on how you look at it. It's not really wider; it's more of more being stretched vertically. But people describe that in many different ways. So, and you can do that. You can plug in some numbers and figure that out when you have changes in HK. But if you know those patterns, pardon me, it's an easier way to go. All right, that's that for graphing rationals. We'll review for about 20 minutes at the beginning of class next class, and then we'll take the test. Have a lovely evening.